Hello guys, I'm back again with another video lesson. If you remember, in a previous lesson we studied the sound intensity in chapter 4 section 2. Intensity is the time rate of the flow of the energy per unit of area. The sound intensity inversely proportional to the square distance from the source of an object from the source, and is directly proportional to the power that emitted by the source at constant distance. But the effective of changing distance of an object from the source has more effective than the power, because according the relation of intensity of sound, I is inversely proportional to the square of the radius. After that, we studied that both frequency and intensity are determinants which sound are audible. So the audibility of the sound or the human hearing does not depend on frequency only. It's also depending on the intensity. For example, according this figure, as we studied in previous lesson, according this graph or this spectrum, this figure, this range between the intensity and the frequency. Like, if you remember, we said the frequencies, low frequency below 50 hertz and the higher frequency more than 12,000 hertz. In both cases, lower frequency and higher frequency require what? Require more intensity to be heard. Okay? So, for example, if frequency is equal to 50 hertz frequency, and at this point, no sound is detected here, okay? Only inside this curve or inside this line, inside the red line, there is a region of sound. The other region, there is no sound here, guys. When frequency is 50 hertz, we cannot say this frequency, the sound of this frequency is audible. Why? Because if the intensity of this sound when it is frequency is 50 hertz is equal to 10 power negative 10 watt per meter square, this sound is not audible. When does 50 hertz, the sound of 50 hertz can be audible sound? If its intensity is about 10 power negative 6, 10 power negative 4, 10 power negative 2, 10 power negative 0. Okay? But the other intensity, the sound cannot be hearing. So according this range, so this is the range of audibility of the average human ears. So this region is called what? Threshold of pain. Guys, in threshold of pain, the value of intensity is more. The value of intensity of sound is more in the threshold of pain, so that is why we call threshold of pain. Sometimes it goes to pain in our ears. So the lower region, this region, guys, is called what? Threshold of hearing. The intensity of threshold of hearing is about 10 power negative 12 watt per meter square, but the intensity of threshold of pain is about what? 10 power 0 watt per meter square. So the range of the intensity of sound is between what? 10 power 0, okay, which is equal to 1. Instead of 10 power 0, you can write down 1 watt per meter square to what? 10 power negative 12 watt per meter square. This region is called threshold of pain. Is called what? Threshold of pain. It has more intensity, but this region, when its intensity is equal to 10 power negative 12 watt per meter square, this region is called a threshold of hearing. Threshold of what? Of hearing. But the range of frequency, so this range is very important. Be careful. The range of frequency, as we studied, between what? 20 hertz to 20,000 hertz. What is this? This is the range of frequency, but the range of intensity between 1 watt per meter square to 10 power negative 12 watt per meter square. What is threshold of hearing, which is equal to 10 power negative 12? The threshold of hearing, its definition is very important. Pay attention. The softest sound. Why threshold of hearing is the softest sound? because its intensity is too less. Okay? The softest sounds that can be heard by the average human ear occur at which frequency, guys? About thousands frequency. If you look the spectrum, guys, look. According to this figure, this region is threshold of hearing. This region is what? Threshold of hearing. Why? Because it is intensity 10 power negative 12. When the intensity is equal to 10 power negative 12, this frequency is about what? 500 to 1000 hertz. Okay? So the threshold of hearing is located at 1000 hertz. Occurs at which frequency? About 1000 hertz, less than 1000 hertz, or more than a little than 1000 hertz. And this intensity is equal to what? 1 times 10 power negative 12 watt per meter square. What is the value of threshold of hearing? You have to keep in your mind. You have to memorize this number, okay? The value of threshold of hearing is equal to 1 times 10 power negative 12 watt per meter square. What about threshold of pain? According to its name, threshold of pain, it has more intensity. So that is why we have to say the loudest sounds. What is threshold of pain? Loudest, opposite of threshold of hearing. Loudest sound, threshold of pain is the loudest sounds that human ears can tolerate or can detect, have an intensity about what? The intensity of threshold of pain is equal to 1 watt per meter square. So this is the range of the intensity. Guys, we have some notes. Pay close attention, please, and listen carefully. Note number 1. The frequency of sound waves heard by the average human range from which range? 20 hertz to 20,000 hertz. We have studied this. Note number 2. Intensity is also a factor in determining which sound waves are audible. Okay, if someone asks you, which of the following has a factor or determines which sounds are audible? Frequency or intensity? Both of them. Both frequency and intensity, they can determine which sounds are audible. Not only frequency, not only intensity. Sounds in the middle of the frequencies range are easier to hear than the lower or higher frequency. Which sounds can be heard easily in the spectrum, in this range? Which sound can be heard easily? The sounds at the middle of the spectrum or at the end of the spectrum? Absolutely at the middle of the spectrum. Why? Why the sounds of the middle of the spectrum can be heard more easily than these regions, than in this region or this region? Because at the middle of the spectrum, the sound can be heard with a little intensity. But for example, at this region, we need more intensity for the sound to be hearing. At the end of the spectrum also, we requires more intensity for the sound to be hearing. But at the middle, at this region, we need only a little intensity for the sound to be hearing. Okay, so which frequencies are easily, in which of the following frequencies the sound can more be easily to be hearing? Lower frequency, higher frequency, or at the middle of the spectrum? At the middle of the spectrum. The frequencies of the middle of the spectrum can be hearing more easily than than this region or the end of the spectrum, because they require less intensity. Sounds in the middle of the frequencies range are easier to hear than the low or high frequencies. Sounds at low frequencies, those below 50 hertz, or high frequencies, those above 12,000 hertz, requires what? Requires more intensity. Okay, the frequencies at the beginning of the spectrum or at the ending of the spectrum, low frequency and high frequency, requires more intensity to be hearing. Some of human can hear slightly softer sounds. So this is a special case. If you look the spectrum, guys, look. Okay, guys, look at the spectrum. The sounds at this position is about 3000 hertz, guys. Here, intensity is about 3000 or 3300 hertz. This frequency, this is special case, not everybody, some of the human ear can detect this sound also below less than 10 power negative 12. So the peoples in this range, when they can find the audibility of the sound at 3300 hertz, they require less than 10 power softest than the threshold of hearing. It should be negative 13, okay? As I mentioned here, sounds are some not all, okay? This is special case. Some human can hear slightly softer sounds less than 10 power negative 12, at which frequency? 3300 hertz. The loudest sounds that the human ear can tolerate have an intensity about 1 watt. This is known as the threshold of pain, because sounds with the greater intensity can produce what? Can produce pain. That is why we have to say threshold of pain, or we call the threshold of pain in addition to hearing. The highest curve represents the threshold of pain. The threshold of hearing at each frequency is represented by the lowest curve, okay, located at the lowest of the spectrum. And number 9, exposed to sounds above the threshold of pain can cause immediate damage to what? To the ear, even if no pain is felt. But so that is why the prolonged exposure to sounds of the lower intensities can also damage. Okay, not only the sounds of the higher intensity can cause damage our ears, even the sounds with the lower intensity can also damage the ear. For this reason, many musicians wear the earplugs during their performance. Okay? Note number 10, the last one. Note that the threshold of hearing and the threshold of pain merge, or they are reaches to each other at both high and low ends of the spectrum. Look at this question. Why many musicians wear the earplugs during their performance? Because the sounds above the threshold of pain can cause immediate damage to what? To our ears. Even if no pain is felt directly. Maybe after a while you will feel this damage. Only the higher intensity cause to damage our ears? No. Also the sounds of the lower intensities can also damage the ears. That is why the musicians, they wearing earplugs during their performance. Question 25 in chapter review, guys. Why does the vibrating string sound louder when it is on an instrument than it does when it is stretched on a workbench? To increase the area, or to increase the vibrating area. Okay, as I told you, one factor that can cause to increasing the intensity of sound, increasing the area of vibrating source. The area of what? Of vibrating source. For example, now I'm going to bring tuning forks. Guys, look at this tuning fork. This is tuning fork. If I strike the tuning fork, the sound can produce, but we cannot hear the sound, okay? Why? Because it is vibrated area is too less. How can we increase the vibrating area? For example, if we strike the tuning fork and touching or fixing on the smartboard or the whiteboard, you can easily hearing the sound. Why? Because when we strike the tuning fork and attach it to the smartboard or the whiteboard, in that case, the vibrating particles transferred into the whiteboard, and because the whiteboard has enough area, it goes to increasing the intensity of the sound. So that is why in the instrument, the strings of the guitar or piano, it should be fixed or attached at the body of the guitar. Why? Because when we stuck the strings of the guitar, the vibrating particles of the string is transferred to the body of the guitar. So in that case, the body of the guitar has more area. This vibrating area will increase, and it goes to increasing the sound intensity. Because the guitar's body transferred the string's vibration to the air more effectively, which increased the sound intensity. It goes to increase the area of the vibrated source. Look at the sample problem, guys. Just for reminding you, as we studied in previous lesson, intensity is equal to what? Power of area. If power and area is given in the question, you can use this equation. But if area is not given, instead of the area, the distance is given, you can use this relation. Area of sphere is equal to 4 pi r square. Why? Because the sound propagates as a spherical wave. The area of sphere is equal to 4 pi r square. Look at sample problem 4a. What is the intensity of sound? Guys, what is unknown? This is sample problem. Sample problem 4a. What is unknown? The intensity of sound is unknown. Look. Produced by a trumpet at a distance. What is this 3.2? This is distance from the source. At a distance 3.2 meter. If this distance is given in centimeter or millimeter or kilometer, you have to convert to meter. When the power output of the trumpet is 20 watt, what is the value of power? 20 watt. Assume that the sound waves are spherical. The area of spherical is 4 pi r squared. Guys, which equation can be used? Equation number 1 or 2? Equation number 2, because intensity is equal to power over 4 pi r squared. Do we have power? Yes, was given 20. Too easy question. 4 times 3.14 times r was given 3.2. Intensity equal to what? Intensity is equal to 0.16. 0.16 watt per meter squared. Another question in practice 4a, question 1. Look at question 1 in practice 4a, very good question. At a maximum level of loudness, the power output of a 75 piece of orchestra, how many pieces do we have? The amount of piece is equal to 75 piece of instrument. How many instruments do we have? 75 instruments in an orchestra. Okay, in the orchestra we have 75 piece of instrument. Radiated as a sound is 70 watt. What is this? This is the power for all instrument, guys. What is this power? For all instrument. All instrument, which is equal to 75. Is equal to what? The power for all of them? 70 watt. Is it clear? 70 watt. This power for how many pieces? For all of them, for all pieces. What is the intensity of this sound? What is unknown? Intensity. For how many pieces, guys? All of them. For all pieces. The intensity for all pieces is unknown. To a listener who is sitting 25 meters from the orchestra, R is equal to what distance of the listener from the orchestra is 25 meter. Is 25 meter. Now we have to solve this question to find intensity. Intensity for all instrument is equal to what? Power over 4 pi r squared. Power for all pieces is equal to what? 70. Divided by 4 times 3.14 times r, 25 squared. Is it clear? Yalla. Intensity for all of them is equal to what? Is equal to 8.91 times 10 power negative 3 watt per meter squared. Okay, what is this? This is the intensity for all pieces. Guys, to find the intensity of sound for one piece, for what? For one piece, we have to divide this value by 70, okay? It's gonna be for one piece. For example, to find the intensity of the sound wave for for 5 pieces, how can you determine intensity only for 5 pieces? The intensity for 5 pieces is equal to this number, 8.91 times 10 power negative 3 over 70 times number of pieces that you want to find. If the questions ask us to find what will be, or what is the intensity of sound for 10 pieces or 5 pieces? To find for 5 pieces, you have to divide the final result for all of them, divide by 50, times what? Times 5. In that case, you will get the intensity only for 4 pieces is equal to something watt per meter square. This is question 1 in practice for A. Question 2, if the intensity of person's voice is 4.6 times 10 power negative 7 watt per meter square. What is this, guys? What is this 4.6 times 10 power negative 7? This is intensity. If you don't understand the questions, you can recognize all physical quantity by unit. So what we have here, watt per meter square. Watt per meter square is the SI unit for what? For intensity. So question 2, intensity is equal to what? 4.6 times 10 power negative 7 watt per meter square. This is intensity of the sound. At a distance 2 meters. R is equal to how many meters? 2 meters. Okay. How much sound power does that person generate? What is unknown? Power. At first, you have to write down the equation of intensity. Power over 4 pi r square. So what is unknown? Power is unknown. Rearrange. 1 times power, power. I times 4 pi r square. I 4.6 times 10 power negative 7 times 4 times 3.14 times 2 square. By calculator, you will get the amount of power, which is equal to 2.3 times 10 power. It should be negative 5, guys. It should be negative 5, not 5. Negative 5 watt. What is this? This is watt because power measured in watt. Guys, question 21 in chapter review. In review and assess. The question says, a stereo speaker represented by P in the figure on the right emits. According to this figure, as you can see here, this is the sound source. Sound waves with the power output. What is the value of power? 100 watts. P is 100 watt. This is question 21 in chapter review. Power is given. What is the intensity of sound wave? What is unknown? Intensity of sound wave at a distance 10 meters. R 10 meters. It's too easy. Just write down the equation of intensity. Sorry, power over 4 pi r square. Do we have power? Yes. Replace. Plug. Times 3.14 times 10 square. I is equal to what? Is equal to 7.96 times 10 power negative 2 watt per meter square. Guys, that's all about the intensity of sound in this section 2, chapter 4. We have another topic, guys. But before explaining this topic, I would like to remind you about the sound wave. Sound has, if you remember, sound has frequency. Sound wave, what is sound wave? Sound wave is a mechanical longitudinal wave or longitudinal mechanical wave. Why? Because sound waves require particles. Without particles, the sound cannot transfer its energy. The energy of the sound transferred by it is by the particles. So the sound is faster in solid than liquid and gas. Okay? And the particles of the sound wave vibrating parallel to the direction of the wave. So that is why sound wave is a longitudinal wave. And also it has wavelength. It has speed. It has amplitude. Okay, which is directly proportional to the energy. And the sound also has pitch. Has what? Pitch. Sound has intensity. Intensity. Okay? So sound has what? Loudness. Or relative intensity. Or what? Relative intensity. Okay, we studied all of them. Okay, so the last thing that we study about the sound is what? The loudness or relative intensity or decibel level. What is relative intensity? Relative intensity is measured in decibel. Okay, what is the SI unit of relative intensity? So in other ways, sorry, relative intensity has no SI unit. Okay, but we assume it that the scientist who discovered this, his name is Bell. Okay, Bell was the first scientist who discovered this relative intensity for the sound, which is measured by decibel. Okay, Bell is not in the SI unit. This is assumed unit. Relative intensity or decibel level is the ratio of what? Guys, listen carefully. Is the ratio of the intensity of a given sound to the intensity at threshold of hearing. What is that relative intensity? Guys, relative intensity. Relative intensity. Its symbol is beta. Okay, what is beta? Is relative intensity or decibel level. You can say beta is what? Relative intensity, or you can say a decibel level. Okay, it has two names, relative intensity or decibel level. Beta measured in what? Decibel. Okay, what does the decibel level measure it in? It measured in decibel, dB. The decibel level beta is equal to what? The ratio of what? The sound of a given intensity. The intensity of is the ratio of the intensity of a given sound, okay, given sound to the intensity of what? At threshold of hearing. Threshold of hearing is I naught. What do you mean by I naught? Is equal to 1 times 10 power negative 12 watt per meter square. What is this? This is threshold of hearing. Threshold of what? Hearing. The threshold of hearing, its symbol is I naught. I naught is constant. Threshold of hearing is constant. You have to memorize. You have to keep in your mind. Okay? Its magnitude is equal to 1 times 10 power negative 12 watt per meter square. Relative intensity is the ratio of the intensity of a given sound, okay, a given sound to the intensity at threshold of hearing. But the relation between relative intensity and the intensity of sound is logarithm. Is what? Is logarithm, guys. Pay close attention. 10 logarithm. What is this? This is the equation of relative intensity. Once again, guys, listen carefully. Intensity or decibel level or relative intensity, decibel level or relative intensity is what? Is the ratio of what? The intensity of a given sound to the intensity at threshold of hearing, I over I naught. But the relation between relative intensity and the ratio of the intensity is not directly, guys. It is logarithmic. It is what? It is logarithmic. So that is why in the equation of decibel level, we have logarithm 10, logarithm intensity of given sound to the intensity of at threshold of hearing. What is I naught? Threshold of hearing. What is this? Intensity of a given sound. What is this? This is relative intensity. Actually, the decibel level has no unit, is unitless, like angular displacement. Is what? Is unitless. Why is unitless? Because it's the ratio of two intensity. Watt per meter square cancel with watt per meter square. Okay? But the scientists, they assume that the unit, so they named the unit of the decibel level as a decibel. What is the unit, or which of the following can be used for measuring the relative intensity? Decibel, which is equal to 10 logarithm I over I naught or I over 10 power negative 12. What is beta? Relative intensity in decibel. I, sound intensity in watt per meter square. I naught, threshold intensity, which is equal to, or threshold of hearing, which is equal to 10 power negative 12 watt per meter square. What is decibel? A dimensionless. It has no dimension. a unit describes the relative intensity of sound. 1 bell is equal to 10 decibel and 1 decibel is equal to 0.1 bell. This D is a prefix. What does the loudness depend on? Loudness, higher intensity. What does the loudness depends on? It depends on the intensity, but it is not directly. Guys, this is described as the loudness. Described as what? Loudness. When relative intensity gets more, loudness also gets more. But this relation is logarithmic with I naught. Is what? Not directly, is logarithmic. What does the loudness? What does loudness depend on? It depends on the intensity, but it is not directly. Instead, it is logarithmic. What does loudness, beta, depend on? It depends on the intensity, but it is not directly. Its relation is logarithmic. Why the loudness is not directly proportional to the intensity? This is very important. Why the loudness is not directly proportional to the intensity? It depends on the senses of the human ear. Because the sensation, okay, the sensation of loudness or our ears is approximately logarithmic in the human ear. For example, if one generator is working, okay, what is this? Generator or machine, okay? What is this? This is machine. Okay, if one machine is working, it is loudness or decibel level approximately 85 decibel. Okay, so with the intensity 10 power, for example, negative 5 watt per meter square. Okay, if we add four or five machines, okay, if we add 3 machines, what happened to the beta? The decibel level is not directly proportional. We cannot 3 times 85. This changing of decibel, by changing the intensity gets more and more, okay? It's gonna be, the intensity gets higher when the number of machines increases. Guys, by adding number of machines, what happened to the intensity? Intensity gets more and more. But the increasing of decibel level is increasing a little, gradually, not directly, okay? We cannot say 4 times 85, but here, by adding 3 machines, we can say I for all machines is equal to 4 times 10 power negative 5 watt. But for the decibel level, we cannot say. The increasing of decibel level is logarithmic, not directly. Maybe it's gonna be, after adding 3 machines, it's gonna be 87 decibel. Okay? The increasing of relative intensity is changes a little, not too much, not like intensity. By increasing number of machines, what happened to the intensity? Intensity is that increasing directly. But by increasing the number of machines, the sound intensity or decibel level does not increasing directly, instead increasing logarithmic. And logically, for example, if one of the machine is working, it has too noisy and it has a loud sound. By adding another machine instead of the first machine, what happened to the loudness? The loudness becomes more, but not too much, a little bit. By adding 3 machines, for example, in the room without machine, there is no sound. The room is very calm. Okay, no sound, no noisy, no loudness. Okay, for example, if we turn on the machine, okay, one machine, if we turn on one machine, this machine can produce a very loud sound. Okay, this machine can emit a louder sound. Okay, loud sound. Okay, but by increasing another machine, or by increasing 2 machines or 3 machines, the loudness beta increases, but not too much. It will be very small. This increasing is very little, not too much. What is the difference between intensity and decibel? Guys, this is very important. Intensity and decibel level. Intensity is the Time rate of the flow of the energy per unit of area measured in watt per meter square. Okay, it is inversely proportional to the distance, but decibel level is the ratio of the intensity in a given sound to the threshold of hearing, but logarithmic. Okay, intensity is power per unit area, but decibel level is a measure of the relative intensity. Just we have some notes, just as the frequency of the sound wave determines its pitch, intensity of the wave approximately. Guys, as we studied, frequency of the sound determines what? Pitch. Look, this is very important. Guys, look, when pitch changes, when we say changes, maybe gets more or gets lower, okay, increase or decrease. Or when loudness changing pitch, changing loudness. By changing pitch, which of the following changes? Does the frequency changes? Yes. By changing pitch, frequency also changes. By increasing pitch, frequency gets more. By decreasing pitch, frequency gets lower. And when the frequency changes, what happened to the wavelength, guys? Wavelength also changes? Yes. Wavelength also changes. So, by conclusion, can we say by changing pitch, both frequency and wavelength change also? Yes, of course, we can say like that. Okay, because pitch is directly proportional to the frequency. When pitch gets more, frequency also gets more. When frequency gets more, wavelength gets less. So by changing frequency, wavelength also changes. But by changing the loudness, when the sound gets louder, which of the following changes? Guys, by changing the loudness, intensity changes. Okay? Relative intensity changes also. And amplitude also changes. Why? Because when energy gets more, the emitted energy, what happened to the amplitude? Amplitude also changes. When amplitude gets higher, what happened to the intensity? Intensity also gets higher. When amplitude gets more, what happened to the relativity? Also gets higher. So can we say by changing loudness, intensity, decibel level, and amplitude, all of them changes with changing loudness? Yes, sure, we can say all of them changes by changing loudness. By changing loudness, does the frequency and wavelength changes? No. By changing loudness, frequency and wavelength stay constant, but by changing pitch, frequency and wavelength constant. But in both cases, guys, speed of sound in both cases, by changing loudness and pitch, speed of sound does not change. Okay? By changing speed of sound, by changing loudness and pitch, speed of sound does not change. When the speed of sound changes? When the medium changes, when the temperature changes, when the properties of the temperature of the medium, such as temperature and density and pressure, changes. Sound speed changes by changing medium. But sound at a given medium, at a given temperature, at constant temperature, at a given medium, sound speed does not change. By changing frequency, does not change. For example, when you are sitting in the orchestra, okay, so it has many instruments. All instruments, they have a variety of frequencies and wavelength. But all orchestras, the sound for all instruments are reaching our ears at the same speed. Like frequency of piano is different with the frequency of the guitar. And it is their wavelengths also are different, but all they have the same speed at a given medium, at a given temperature. By changing pitch, by changing loudness. By changing pitch, frequency and wavelength changes. But by changing loudness, intensity changes. decibel level changes, amplitude also changes. In both cases, speed of sound does not change. Look at this question, guys. In the section review, we have questions that related with this topic. Okay, look at question 3. In critical thinking, look at this question. Which of the following factors change when a sound gets louder? When sound gets what? By louding the sound, when the sound gets louder, it means that the loudness increases. By changing the loudness of sound, which factor, which of the following changes? Does the frequency and wavelength changes? No. Only intensity, decibel level, and amplitude. Look, intensity changes by changing loudness? Yes. Intensity, speed of sound wave changes by changing loudness? No. Frequency changes by changing loudness? No. Decibel level changes by changing loudness? Yes. Wavelength? No. Amplitude? Yes. But when sound gets louder, amplitude changes. Intensity changes. Decibel level changes. The factors that do not change is what? Wavelength, frequency, speed of sound. The second part of the question. Which change when pitch gets higher? By changing pitch, which of the following changes? Frequency and wavelength. But when the pitch gets higher, does the amplitude changes? No. Wavelength? Yes. Frequency? Yes. Intensity? No. Decibel level? No. Speed of sound? No. What about by changing medium? By changing medium, does the amplitude change? Yes. Why? Because the speed of sound also changes. The amount of the energy that passes through the medium changes. Wavelength also changes. Frequency does not change. Why? Because frequency changes by changing source only. And intensity change, decibel change, all of them change it, but speed of sound, but the frequency remain the same. So this question was very important, so it has been brought in the Wizari exam many times, guys. Pay close attention, please, for the question 3 in critical thinking. Okay. The relation between decibel level or relative intensity with the intensity is indirectly, or we can say is logarithmic. So that is why we say relative intensity. Want to be changes. The sound relative intensity is directly proportional to the logarithmic ratio of the intensity. The sound relative intensity is directly proportional to the logarithmic ratio of what? Of the sound intensity. Okay? Yalla, guys. We have some changing of decibel and change in intensity. Guys, look at this table, it's very important. If the sound changes by factor of 10, okay, the intensity of the second sound is 10 times the intensity of the first times. Change in decibel level is equal to what? Is equal to 10 decibel. When does change in decibel level is equal to 10 decibel? When the intensity of the second sound is 10 times the intensity of the first sound intensity. The second one, when intensity of the second sound is 100 times intensity of the second of the first sound intensity, delta B is equal to what? How many zeros do we have here? 2. If this change becomes 20 decibel. Okay, how many zeros do we have here? 1. Write down 1. If the change intensity I2 is equal to thousandths of I1, what happened to the delta B? How many zeros do we have? 3. This 2 is gonna be 3. 30 decibel. So when the intensity gets more and more, it is decibel level changes a little bit, not too much. Okay? So when intensity is equal to, guys, 1 over 10, in that case the intensity decreases. Okay? What happened to the decibel level? The decibel level delta B becomes what? Becomes negative 10 decibel level. When I2 is equal to 1 over 100, I1 delta V is equal to negative 20 decibel, and so on. This is very important, and we have a question to solving by using this relation to solving the questions. Guys, look. When the intensity, what happens to the intensity if you are moving downward? As you can see here, the intensity from 10 power negative 12 to 10 power 3. This increasing is very, very much. Okay? This increasing is very big from 10 power negative 12 to 10 power 3. What happened to the decibel level? 0 to 150. Guys, look, this is 10 power 0, threshold of hearing. What is this? Threshold of hearing. At threshold of hearing, guys, when I naught is equal to 1 times 10 power negative 12 watt per meter square, threshold of hearing, sorry, this is threshold of pain. At threshold of hearing, the first number, the value of relative intensity is equal to what? Is equal to 0 decibel. When does relative intensity or decibel level is equal to 0 decibel? At threshold of hearing. Now I'm going to prove this value. What about at threshold of pain? This is threshold at threshold of hearing. At threshold of pain, at threshold of pain, I naught is equal to what? 1 watt per meter square, or 10 power 0. 10 power 0 watt per meter square. At threshold of pain, beta or decibel level is gonna be 120 decibel. Okay? So this is the range of decibel. If the loudness of sound increases, sound intensity, decibel level, and amplitude also increases. But speed of sound, frequency, wavelength does not change. If the pitch sound increases, frequency increase, wavelength decrease, speed of sound does not change. This is the range for intensity, decibel level, and frequency. The range of intensity between 1 to 10 power negative 12. Decibel level 120 to 0. Frequency 20,000 to 20 hertz. Guys, we have some equations of some rules according math basic for the logarithm. Logarithm 10 is equal to 1. Logarithm 1 is equal to 0. Logarithm A times B is equal to logarithm A plus logarithm B. Logarithm A over B is equal to logarithm A minus logarithm A minus logarithm B is equal to logarithm what? As you can see here, is equal to logarithm A over B. Okay? Guys, inshallah, in the next lesson, we are going to solve these questions, and inshallah, we will explain section 3 in chapter 4. After that, inshallah, we will explain chapter 5, chapter 6, 7, 8, and 9. As I promised you, I'm going to explain the whole books of the physics for grade 12 students. Thanks for listening. Keep up your best doing.